Hi everyone, this is Gunjan and this is my submission for my digital assignment of subject information security analysis and audit. And today I'm going to present before you an interesting technique to hide data inside images. This is called as steganography. Steganography, as mentioned, it is the art of hiding data inside images. Now let us look how this technique works. So first of all, let's understand the RGB color model of the image. RGB stands for nothing but the red, green, blue. Each image can be separated into three color channels, namely red, green, and blue. The image consists of a pixel, and each pixel has three values, that is red, green, and blue, which is separated into two channels. And here we are considering 8-bit pixel, and the range for this pixel, since it's 8-bit, it will range from 0 to a maximum limit of 255. So this is what an image looks like. Each square over here, each minute square over here, this represent one pixel. This mini square represent one pixel. This mini square represent one pixel, and each pixel has its own RGB value. So, for example, if I take this pixel, it has its RGB value as 218, 150, and 149. If I represent it as a 8-bit binary code, it can be represented in this format. So this was the RGB color model of the image. Now, let us see an interesting phenomena in this binary code. While decoding the decimal value into binary code, we assign weights to each of the bits. So the LSB has a weight of 1, whereas the MSB for an 8-bit digit has a weight of 128. And the decimal representation of the equivalent binary number is given by multiplying the value of each bit by its corresponding weight. Now, why do we call these bits as LSB and MSB? So, if I take this number, which is the 8 times 1, its value is 255. If I change the rightmost bit, that is the LSB, the value comes to 254, which is not a very significant change. The difference is less than 1%. But if I change the leftmost bit, the value drops to 127. So you can see, like, changing the rightmost bit and changing the leftmost bit has how much effect. So like changing the leftmost bit, that is the MSB, has large effect. That's why it's called as the most significant bit, because it has large impact on the value of the number. Now, why am I telling this MSB and LSB concept over here? Let's see. The MSB and LSB concept has an important role to play in the steganography. Now, let's see how it has to be done. This is a color strip in front of me, and this color strip is basically divided into squares. So this portion over which I am moving my pointer, this portion basically consists of 4 squares, but the colors are so close that the squares are almost indistinguishable. Whereas in the later ones, you can see the color variance and you can easily figure out the squares. Now, the leftmost square, on which my pointer is moving, has the RGB values as this one, the highlighted ones. Now, as we move from left to right, we are flipping the most significant bit. Like we are making we are flipping the rightmost bit. That is, we are making the LSBs as 1. So if I move from first square to the second one, we have made the rightmost bit as 1. From second square to third square, we have made the second rightmost bit also as 1. That is, 2 rightmost bits have changed. Going on, so on. When we come to the last square, we have basically flipped all the bits. So you can see that the R value, which was 4 times 1 and 5 times 0 over here, now it has become, the value has completely flipped over here. The green value is also completely flipped over here, and the blue value is also completely flipped over here. Now you can see that the color change is almost indistinguishable till 4 squares. That is, till here the color change is almost indistinguishable. What this tells us is that if we remove 4 pixels from the right part, that is, if we remove the 4 LSBs of a bit, if we change the 4 LSBs of a bit, it won't have a much impact on the color code. If we change the 4 LSBs of a bit, it won't have a much impact on the color code. This statement is very important if we are going to hide data inside images. But after changing the 4th bit, you can see that the color variance becomes significant. So now I am going to show you how we are going to hide data inside images. we will take the four most significant bits of the cover image. Cover image is the one image inside which we are going to hide data, and four most significant bits of the hidden image. Why we are taking four most significant bits of the hidden image? So that during the retrieval, the quality of the hidden image won't be affected much. I'm going to explain you with this thing with an animated example. Let us see that. So over here, I'm sorry. Yeah. So over here, this red block represents the cover image, and this green block represents the image which we want to hide inside the red block. This is the RGB values of both the images. Let us see how it's done. This I have converted into the binary representation. Now what I am doing is I have taken the R value of this. I have taken the R value of this green square. We have placed them together. Now let's see the magic. Now, what we have done is we have taken the four most significant bits of this cover image and four most significant bits of this hidden image. We have combined them together to make new 8 bits. That will be my resultant image. We are doing the same procedure with all three things, R and G and B. So now you can see that this is my ready image which is ready to be transmitted over the network. Now you can see that this final image and this cover image, they are almost indistinguishable. Naked human eye cannot distinguish between the color of these two, and you can see that the RGB values are also closer, but inside this green image is hidden. Now let us see how do we extract this green image from this red image. Now what we have done is, as during encoding time I told you, we are this four LSBs of the stego image, that is the image which contains the hidden data. So these four LSBs of the stego image, they are nothing but the four MSBs of the hidden image. So what we are doing is we are extracting the four LSBs of the stego image, and we are appending zeros against it. As I already said earlier, flipping the least significant bits of an image doesn't have much impact on its color. And here we have appended zeros, and when we decode it to decimal and we get the color output as green, now you can see that this green image and this green image is almost indistinguishable. So we have successfully hidden an image inside another image and then retrieved it. And you can see that the RGB values are also quite closer. So this was the explanation how it is done. Now let us look at the implementation. Over my screen, I will show you how the implementation is done. First, I will show you how to inside an image inside the I will show you how to inside one image inside another image. So this the image which you are seeing on my screen, the city image, it's going to be my cover image. That is, this image will carry another image inside itself, and this cartoon image I am going to hide inside this city image. Let us see how it's done. I have written a Python code for that. So this steganography.py will execute. I will give path of my cover image first, which was images slash city dot, just a minute, city dot jpeg, and the image which I want to hide, which was images slash shinchan dot jpeg. Now it will hide this cartoon image into this city image, and it will save finally the stego image, that is the merge image, merge.png. You can see over here, this is my merged image. But compared to the original image, you can see that the sharp corners have somewhat blurred over here. Why? Because we have removed the LSBs of this image, as I showed you during the explanation of the technique. Now let me show you how to hide data inside this image, that is the text data. Here I have taken a random text from a novel. So this text now I'm going to hide inside the image. Let us see how it's done. Again, I will give first the path of the cover image, that was city.jpg. I'm going to use the same image as cover image. And now I'm going to give the path of my message file, that is the text which I want to embed inside the image. That's message.txt. and it says me that cover image with secret message is saved as original file name with underscore hidden.bmp. Basically bmp format doesn't compresses the image, so the quality loss is not that much. So you can see that a new file name city underscore hidden.bmp is created over here. So you can see that there is no much difference between the cover image. This city.jpg is my cover image. On the top left corner you can see the name, and this city hidden.bmp contains my hidden message. Let us uncover this hidden message also. I will show you how. Again the same file, but this time instead of 2 arguments I am going to give 1 argument to it. Images slash the name of my image city underscore hidden.bmp. Now you can see that it has printed the entire novel which I encoded over here. Not exactly entire novel, the entire text which I encoded over here. So this was my implementation of that. I can also show you how the decryption of the the unmerging of the image inside another image is done. So as I told you earlier, this merge.png contains one hidden image which I showed you earlier. So now let's unmerge it. Merge.png. It will tell me that hidden image is saved as unmerged.png. So you can see here a new file called unmerged.png. Yes, it's created over here, and you can see that I've retrieved the hidden image successfully. What was this Python code? This Python code I have uploaded in my GitHub account also. The link for that is given in the description, which you can find right below the video. I'll share the link to it. This is the image, this is the main file, the steganography.python file, and it's calling the suitable models. The respective models to hide text, to merge image, and to unmerge are listed over here. So now coming to the main part, this was the implementation of the steganography algorithm. This steganography technique is called as LSB steganography technique. There are more steganography techniques available. One of the most famous one is also BPCS steganography, which uses bit planes instead of the image bits which we have considered. Now let us see how the evolution of steganographic data carriers have been over the ages. Steganography is not a very new technique. It has been practiced over the ages. So like in earlier the ancient Greek times, they used to transmit data by hiding it over a wooden tablet or a human skin, or during the Middle Ages they used to hide data on eggshell, or they used to simply flip the alphabets as a linguistic syntax. Now during the 20th century, many cryptographic protocols came. We know RSA algorithm, we know AES algorithm, but that's related to cryptography, and then came the digital text. Now in present time, we not only encode data inside images, but we encode it basically inside any file, or your operating file system, your any digital media, whether it be video, whether it be audio, whether it be any file, whether it can be PDF file also. You can embed data inside network protocol also. So basically, hiding this data into another carrier is basically steganography, and this was the evolution of steganography over the ages. Now let us see what are the applications and advantages of steganography. The main use of steganography lies in watermarking and DRM. What is DRM? Digital rights management. Suppose a movie has to be supplied to a movie theater vendor. So how to assure that the movie is not leaked? They will basically hide a secret code inside the movie video, and if by chance the movie gets leaked, they can retrieve that secret code, as we have seen how we retrieve that inside the images, and using that secret code they can trace that which vendor leaked that movie. Then protection of data alteration. We can design specific algorithms such that if data is altered while retrieving it back, there is a large change in the hash value or something like that. Then we can use steganography for intellectual property offenses, like the intellectual property is not leaked by someone, or even if it's leaked, we can trace that who leaked it. And we can also use steganography for confidential communication, which is the most obvious reason, and secret data storing. The most important advantage of steganography lies that the messages do not attract attention to themselves. Like if we encrypt the data by using RSA or AES algorithm, the encrypted text. The cipher text is like it looks like, yes, that's a hidden data. Any layman can identify the ciphertext as like it's encrypted, but no layman can identify whether data is hidden in an image or not. So that's the most important advantage of steganography. Like it's almost undetectable. So this was my presentation on steganography. Thank you very much for watching this video with your patience. Myself Gunjan Agrawal, and my registration number is 18BC1168. Thank you. Have a nice day.